average versus instantaneous velocity. In order to show you the difference between those two, an application that I like to start with would be a trip. So let's say that I drove to my cabin, which is about 300 miles away, and it took me 5 hours to get there. Hey, we rarely drive at a constant speed, so let's graph this. The variables I chose would be time in hours and distance in miles, and because of traffic flow and various reasons, let's say that we ended up having to take a detour and go backwards, and we ended up in this position right here. So according to what I said earlier, this distance and time was 5 hours and 300 miles, which creates the ordered pair 5 and 300 and 0, 0. And if I want to measure the average velocity, most people just do this in their head, but technically it's a measurement of the change in distance over the change in time. So in our situation, we would take 300, which in our case would be miles, divided by the time, which is 5 hours, which gives us 60 miles per hour. I'd also like you to think of this graphically as, if you imagine a right triangle here, essentially that number 5 is your change in x and the number 300 is your change in y. So in all actuality, what you just did is you found the slope of that line, which we refer to as a secant line. Now I want to think of this in terms of instantaneous velocity. And we know that our average speed is 60 miles per hour, but that's going to vary. So if you look at the steepness along the curve, anytime that the curve is steeper, we're going to be traveling a little bit faster. And anytime that it flattens out, we're going to be traveling a little bit slower. And I think that's pretty intuitive. But what we want to think about here is, geometrically speaking, what are we measuring if we're talking about instant speed? So before, we know the average velocity is the slope of the secant between these 2 points, but I want you to think of the instantaneous velocity in a little bit different way. Each point along the curve, the steepness here seems to be changing somewhat. So what I want you to think of is this being the tangent line, and we said before that the slope of a tangent is really the same thing as the slope of the curve. So if we could find the slopes of each of these tangent lines, in all actuality what we would be finding is instantaneous velocity. It may be as little as 0 right here at the top, and it may be fast as, in this case, let's say 75 miles an hour, but it will vary, but we can calculate it with the slope of a tangent. In summary, the key thing to remember about the difference between average and instantaneous velocity is geometrically how it's measured. If you want to find the average velocity from this time to this time, it's measured as a slope of a secant line, whereas instantaneous velocity is at a specific moment in time, measured by the slope of a tangent. And if you can remember that geometrical connection, you're exactly where you need to be.